Hello students, in this video we are going to evaluate some definite integrals using Cauchy Residue Theorem. This is part 2. Already I have posted a video to evaluate definite integrals. These integrals are type 2 integrals. Either they are of the form minus infinity to plus infinity f of x dx or integral 0 to infinity f of x dx. For this integral, I have posted a video. I have done a problem of this kind. In this video, we are going to do a problem of the form integral 0 to infinity f of x dx, where f of x is equal to g of x by h of x, where g of x and h of x both are polynomial in terms of x. This is the equation what we are going to use here, integral over c f of z dz. For evaluating this integral, we have to use type 1 method. For this also, we have two videos. Kindly watch those two videos. After watching that, kindly watch this one. So this is equal to integral minus r to plus r f of x dx plus integral over c1 f of z dz, where c1 is a half circle, minus r to plus r is a straight line. The problem what we are going to see now is we are going to prove integral 0 to infinity dx by x square plus 1 the whole square is equal to pi by 4 using Cauchy Residue Theorem. For this, already we know that integral minus a to plus a f of x dx is equal to twice integral 0 to a f of x dx when f of x is an even function. What do you mean by an even function? A function is even when f of x is equal to f of minus x. When we replace x by minus x, if you are getting the same answer, that function is called a even function. For example, if I take f of x is equal to x squared, f of minus x is equal to minus x the whole square, which is x squared. So same f of x we are getting. Such kind of functions are called even function. For that function, we have this result. For example, here if I take the function f of x is equal to 1 by x squared plus 1 the whole square. That is the given term. Now leaving dx, whatever we have, that I have taken as f of x. F of minus x is equal to 1 by minus x the whole squared plus 1 the whole squared. Minus x the whole squared is x squared plus 1 the whole squared, which is same f of x. Therefore, f of x is an even function, right? Therefore, minus infinity to plus infinity f of x dx can be written as twice integral 0 to infinity f of x dx, since f of x is a even function. I told you the property now, minus a to plus a. In the place of a, we have infinity here. So integral minus infinity to plus infinity f of x dx is equal to twice integral 0 to infinity f of x dx. We are going to find this one. So we can bring this 2 to the other side. So what is the final thing we can write? Integral 0 to infinity f of x dx is equal to 1 by 2 integral minus infinity to plus infinity f of x dx. So we are going to find this one first. In the answer, we are going to multiply it by 1 by 2. Is that clear? For that, first I am going to write what is my f of z. F of z means in f of x, in x we are going to replace it by z. 1 by z squared plus 1 the whole square. Right. So now we have to find the poles. How to find the poles? Equating the denominator equal to 0. How many poles we have? Square the whole square. So totally we have to find 4 poles. Okay. Don't say 2. Square the whole square. So it is of the power 4. Okay. So z squared plus 1 equal to 0 implies z squared is equal to minus 1. This minus 1 is I squared. So z is equal to plus or minus I. The whole squared we have no. So 2 times we get. So z is equal to plus I comma plus I 2 times minus I comma minus I 2 times. Therefore, I is a pole of order 2. Also minus I is a pole of order 2. At these poles, we have to find the residues. After the confirmation, If these two poles lying inside the curve, what is the curve we have? We have the half circle with the straight line minus r2 plus r. So this point is 0 comma 1 and this this point is 0 comma minus 1. 0 comma 1 is here. So it lies inside. 0 comma minus 1 is lying outside. So no need to, this lies outside. Lies outside. C1. This lies inside C1. So we are going to find residue for I. So we are going to find the residue of f of z at the pole I. Okay, since I is repeated twice, m is equal to 2 here. So the formula is m minus 1, that is g1 of I by 1 factorial. Am I right? This is the formula, no? So tell me what is my g of z first. My f of z is equal to 1 by z squared plus 1 the whole squared. Am I right? So pole we are taking I. So the corresponding factor for this is z minus I. That alone we have to keep in the denominator, bring all the other terms to the numerator. So I can write this as z minus I for this, z plus I the whole square. This one you keep in the denominator, right? So z minus I the whole square. The whole square we have, no. Take this to the numerator. So 1 by, numerator means I am not asking you to take directly to the numerator. The given term should not be affected. We are rearranging, rewriting, that's all. Directly you don't take to the numerator. So I can rewrite this as 1 by z plus I the whole squared by z minus I the whole squared. Pole we are having I only, no. So the corresponding factor should be there in the denominator. Now this is my g of z. So g of z is equal to 1 by z plus I the whole square. I can rewrite this as z plus I power minus 2. So g dash of z is equal to minus 2 z plus I the whole power minus 2 minus 1 minus 3. So minus 2 by z plus I power 3. Now g dash of I equal to minus 2 by I plus I power 3, 2I power 3. 2I power 3, 2 power 3 is 8, so minus 2 by 8I cube is minus I cube is minus I, so 8 into minus I, this 1 by I can be written as minus I in the numerator by minus 8, 3 minus we have, no. So which is equal to minus 3 minus we have, no. So this term will come in minus sign, 2 we can cancel, this minus and this minus cancelling. So minus I by 4. So this is the residue of f of z at the pole I. Then what is Cauchy residue formula? Integral over C f of z dz is equal to 2 pi I into sum of the residues. Only one residue we have, that is minus I by 4. I squared, I into I squared is minus 1. Already we have one minus sign, so it is plus. This is 2. So plus pi by 2. So integral over C f of z dz is equal to plus pi by 2. Okay. So where we started? This is the equation and here we took, no. This is actually we started for minus infinity to plus infinity f of x dx. This only we started. For that only we have the equation. So this is the equation we have. In that this one only we are getting as pi by 2. Now r tends to infinity means this one integral over c1 f of z dz will tends to 0. So what is the equation we have? Pi by 2 is equal to r tends to infinity. So this integral is minus infinity to plus infinity f of x dx is equal to this thing. But in the problem we don't have minus infinity to plus infinity. It is twice integral 0 to infinity. This is equal to twice integral 0 to infinity f of x dx. Am I right? Which is equal to, the answer is pi by 2 we got. Bring this 2 to the other side. Therefore integral 0 to infinity f of x dx is equal to pi by 4. This is what we have to prove, and we have proved. So, 1 minute. The problem given is from 0 to infinity, but we are not able to solve for this limit. We have to work out for minus infinity to plus infinity. After that, in the final answer, what you are getting, no, that you divide it by 2. Is that clear? If the limit is from minus infinity to plus infinity, directly you work out, and whatever answer you are getting, no, that is the final answer. But if the limit is from 0 to infinity, final answer you have to divide it by 2 if the given function is an even function. Is it clear? Thank you.